All right, this is AP, AB, and BC Calculus. We're doing Unit 8, Section 8, which is more volume with cross sections. This time we're talking about triangles and semicircles. So this is the same concept that we saw in 8.7, just with some different shapes, meaning different plates that go in the dish rack. So a reminder, the area of a circle is pi r squared. The area of a semicircle is 1/2 pi r squared. The area of an equilateral triangle is a equals the square root of 3/4 times b squared. And I'm going to walk you through why that's true real quick. You can also just memorize it. Like this is worth memorizing. It's not hard to figure out, but it is worth memorizing. And just to be clear, also, if you had the area of any triangle in general, so area of just a generic triangle, which sometimes comes up, like sometimes they'll ask you this question, but the area of any triangle in general is 1/2 base times height, which you can see I put right here when I explained why this is this formula. So real quick, the reason an equilateral triangle has that area, if we draw an equilateral triangle, and again, I would suggest memorizing this because it's going to make your life a lot easier. So I'm going to go ahead and call this equilateral triangle base, 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 right? I'm going to say all three sides are base. Okay, so if you look at an equilateral triangle, it's also equiangular, right? These are all 60s. What that means is that if I look just at this triangle, this is a 30, 60, 90 that looks like this. This is a, so this would be H. This is a 30, 60, 90 because this is 60. This is 30 because it was half of that original 60 angle, right? And this is not base, but rather base over 2. So if you recall the ratios of 30, 60, 90 triangles, right? The side that's opposite 30 has a ratio of 1, the hypotenuse has a ratio of 2, and this side has a ratio of √3. So you can set up a proportion between these guys. And what you'll essentially get is that base over 2 is to 1, as height is to √3. So if you solve for the height, you get √3 over 2 times the base. And you'll see that that's what I did here. In place of this height in the triangle formula, I put a √3 over 2, which is how we get that for an equilateral triangle, the area is a 1/2 times a b times a √3 over 2 times a b, which is √3 over 4b squared. So that's where that comes from. You definitely don't have to know where that comes from. You could just memorize it, but having been a person that didn't have this memorized and had to troubleshoot that in the middle of an AP test, it's useful to know that. So let's go ahead and do some examples. So we've seen all these regions before. I'm reusing the regions that we used in the video from 8.7, but we're just going to do different cross sections, right? So some of these are going to be really easy to do by hand. Most of them are going to be easier to integrate on a calculator. Remember that most of the time the AP wants to see that you understand the mathematical setup of the integrand and what it should look like, and then they're fine with you finding the numerical value on a calculator. So we're going to set up the integral, and then notice it says use your calculator to actually find the volume. So this is our region, right? The perpendicular to the x-axis are semicircular plates, such that the diameter is in the shaded region, meaning we're looking at a semicircle plate that comes up like this out of the screen, right? So it's coming towards you out of the screen. This is my diameter. So what that means is that the diameter of this semicircle is top minus bottom. So it's top, which is this curve, √x, minus the bottom, which in this case is just 0 because it's the x-axis. So the diameter of this thing is √x. Well, diameter is the same as double the radius, right? So that means that the radius of this thing is √x over 2. Once I know that, the area of a semicircle is 1/2 pi r squared. So I'm going to get that this is a 1/2, a pi, and an x over 4. My area is going to be pi over 8 times x. So once I know the area of one slice, my volume should be adding the first plate up to the last plate. So I'm going to integrate from 0 to 4 of pi over 8 x dx. Now, I say you can use a calculator. This is one you can do by hand. If you were doing this by hand, so this one is actually doable by hand. Not all of them are. You'll see the difference as we move forward. Some of them are awful. If you did this one by hand, you're going to get that this is pi over 16 x squared, right? Because you'd be dividing by 2. So you'd get that if you did this by hand, you get 16 pi over 16 minus 0. So you're just going to get that the answer is pi. Now we're going to check it in a calculator anyway, right? So if I were putting this in a calculator, I still have to do all the heavy lifting to figure out what this formula for area in terms of x is, right? Again, I could, in a situation where these functions are complicated, I could make this y1, right? I could call this y1 and I could make the radius y1 minus 0 all over 2. There are a bunch of things we'll do as we move forward with harder problems, but in this case, it's easier to just say, cool, I'm going to make this a pi over 8. You also can yank that pi over 8 in front of the integral, right? This is just a coefficient, so if you would rather put this in front of the integrand, you certainly could, right? So pi over 8 times x, comma, with respect to x, from 0 to 4. And there we go. And sure enough, you can't math frac it because it's an irrational number. It's pi, but you can see that that's definitely pi. So even if it's a non-calculator section on the homework, or if it's not a calculator multiple choice, you should still use your calculator to check your answer is right, because that way you know you're building the calculator skill. All right, so same idea. This is the same curve we saw in P1 of the last video, but we're going to do semicircles that are perpendicular to the x-axis. So your plates go this way, right? And your plates are semicircles. So there's a semicircle coming up like this, right? And the diameter is in the shaded region. So you can go ahead and pause me if you want. My diameter is going to be the top curve, which in this case is x squared, minus the bottom curve, which in this case is just 0, right? So my diameter is x squared. Since the diameter is double the radius, that means that my radius is x squared over 2. The area of a semicircle is 1/2 pi r squared. So that's my r squared. So I'm pretty sure I get that this is a 1/2 pi times a 1/4 times an x to the 4th. My area is going to be pi over 8 x to the 4th. Now this is another one where you can definitely do this one by hand. That's not always true. So I'm going to integrate from the first plate to the last plate, so 0 to 2. And just because you can do it by hand doesn't mean you should. I'm going to walk through this one by hand because this would be a reasonable question on a non-calculator section. Some of the ones we're going to see later, you would not be asked to integrate by hand, even though you mathematically can. It would just not be worth it. So again, if you want to yank this pi over 8 out in front, you can, right? That's going to make this an x to the 5th over 5, right, evaluated from 0 to 2. So I'm going to end up getting that this is a pi over 8 times 32/5 minus 0. So I'm going to end up getting 32 pi over 40, but I'm going to cancel an 8 out of that, right? So I'm going to get 4 pi over 5, and that's going to be my answer. So now we can check that on a calculator. Go ahead and hit second enter, and then second enter again, because I want to go up here. And the only difference is I'm going to go ahead and insert that this is an x to the 4th, because really it's the same question. So we'll go ahead and do, I need a second insert after. Second insert to the 4th. Okay, it's the same everything else. There's still a pi over 8. There's still, and then I'm going to change the 0 to 4 to 0 to 2, right? But everything else is the same. So I hit enter. Now, again, I can't math frac this because it's an irrational number, but what I can do is I can check what 4 pi over 5 is, and sure enough, it's the same answer. Or what I could have done is I could have checked that I could have done the integral without the pi over 8. And what I would have found is that it was 32 over 5, which is the part I got before I multiplied by pi over 8. So you could have also done, you could have also done this, right? And then math frac that, because that doesn't have a pi. And sure enough, that's the 32 over 5 that I got. So then I would multiply by the pi over 8. So either answer, so on a calculator section, you would be able to give either the answer that I put here, right? Or you could give 2.513, right? That would also be fine. This one's approximate, this one's accurate. If we went back one, again, you could either do pi or you could do 3.141 or 2, depending, because it's 14159. Anyway, so either of those would be okay. So this is the exact answer, this is the approximate answer, either would be okay. If it were actually a calculator section, I would suggest you use the calculator. Now we're getting in the range of ones where this is not worth it by hand. So this is not fun or easy or really very doable by hand. It is not to say that it's not doable, like you can do it, but it's not a good call, right? So on some of these, I think it's fair to ask you to integrate an x. I think it's fair to ask you to integrate an x to the 4th. Things are about to get really ugly. So we're just going to do the calculator on these examples. We're not going to try and do it by hand. So the region bound by these curves, right, so this blue region, is a base of with cross sections perpendicular to the x-axis. So again, we're talking going this way, perpendicular to the x-axis. And they are equilateral triangles. So what we're saying is coming out of this board is an equilateral triangle that has some base here, right? So The area of an equilateral triangle is root 3 over 4b squared. You don't have to know that. You can figure that out from scratch the way I did a couple slides back, but it's a lot easier if you figure that out. In this problem, the base is going to be top minus bottom. Well, the top is an x squared plus 1, and the bottom is an x. So this base is going to be x squared plus 1 minus x. Honestly, there is no incentive to clean this up at all. You should leave it like that. So the area in terms of x is going to be a root 3 over 4 times this entire ugly monstrosity, just leave it like that, quantity squared. And your volume then is going to be the integral from the first plate, which was at 0, to the last plate, which was at x is 2, so the integral from 0 to 2, of this ugly monstrosity, so x squared plus 1 minus x, whole quantity squared with respect to x. This is what the AP needs to see, and then they need to see that you do an approximate answer. There is no reason to distribute or clean anything up because, again, this is definitely not a by hand problem. So if I'm doing this on my calculator, here's what I'm going to do. I'm going to go ahead and make that y1, and remember, I always put them in the order that they're presented in the problem so I can never get confused about which one's which. So I see the x squared plus 1 first, and then the x. I'm going to quit out of this, right? I'm going to go to math 9. As a side note, if you want to, you could yank this out in front if you want. It doesn't matter, but it might make your life slightly easier. So I'm going to go ahead and put the coefficient out in front. I'm going to do the square root of 3, close that, divided by 4, right? That's my coefficient. I'm going to go ahead and do math 9, right? And then what's in here, this is the thing I called y1 minus the thing I called y2 quantity squared. This is for me, not the AP. I have to tell the AP, like I have to do this on the AP. This is how I communicate understanding. This is so that I remember which one's which. So in parentheses, vars over to y vars function y1 minus vars over to y vars function y2. Close that and square the whole thing. Comma, with respect to x from 0 to 2, right? So notice that the AP is giving you no credit for this calculator notation. You have to write this in the actual mathematical notation you'd write it without the calculator. And then I hit enter, and it gives me an answer, and my answer is 1.905. That's the volume, okay? There are no units in this problem, so I don't invent units, right? It's imperative that you write this math stuff. I don't care if the root 3 over 4 is on the inside or if you pull it out to the front, but you have to write the correct mathematical notation for these things. All right. So go ahead and try this one. Same concept, right? You're going to set it up, but you're definitely using your calculator. This is not a thing you want to do by hand. So here's our region, right? This is our 2 minus x squared, and down here is our negative x. We have cross sections perpendicular to the x-axis, meaning that they go this way, right? Perpendicular to the x-axis. And they are also equilateral triangles. So somewhere in here, there is a triangle standing up out of the screen that has a base here like this. Remember, it's useful to know that the area of an equilateral triangle is root 3 over 4 base squared. In this case, my base is, again, top minus bottom. So the base is going to be the top curve, 2 minus x squared, minus a negative x. And honestly, you could just keep it as minus a negative x. That's great. That means that my area is root 3 over 4. And then this entire ugly, crazy monstrosity that there is no incentive to clean up, quantity squared. So my volume starts at the first plate, which was at -1, and goes to the last plate, which was at 2. So my volume is I'm going to yank the root 3 over 4 out in front. You could leave it inside. From -1 to 2 of this whole ugly thing. Again, if it's a calculator section, there's no reason to change that. Just copy what it is with respect to x, and then type. So for my own benefit, I know I'm going to call that y1, and that's going to be my y2. So I'm going to go here and make this a 2 minus x squared. Right? I'm going to go here and make this a negative x. So I'm going to quit out, and then the cool thing is I can just hit second enter because I just did an equilateral triangle. I have that root 3 over 4. I have y1 minus y2 quantity squared. The only difference is I'm going from -1 to 2. So I just have to insert that -1, double check that my math is all correct, and hit enter, and I get that this is a 3.507. And that's it, right? So again, the AP needs to see this. The y1, y2 stuff is always for your benefit only. This is for you. It is not for credit. So if you want to get credit for communicating understanding, calculator notation and calculator syntax is never going to do it. You have to do the actual math notation. All right, so we're going to do 2 more examples. They will be ones that involve y. Okay, so We've seen this, it's the same trick, you just have to use x's instead of y's in your calculator, right? So now my dishes are perpendicular to the y-axis, meaning they go like this, right? So I'll be integrating with respect to y, and coming off of this are equilateral triangles, right? So there's this base b. Again, it's useful to know the area of an equilateral triangle in terms of the base. Very helpful. Here, because my base goes this way, my base is going to be right curve minus left curve. So the right curve is going to be x equals 2y because that's definitely a line. And the left curve is going to be the x equals y squared minus 3 because that's definitely the curvy one. So the base is going to be right, so 2y, minus left. Okay, that means that the area of this thing is root 3 over 4 base squared. So again, leave it this way, don't clean it up. What's the point? You only clean this up if you're doing it by hand. So my volume is going to be the integral from the bottom y value, which seems to be -1, to the top y value that seems to be 3. So -1 to 3, those are my y values. I'm going to write the coefficient out in front because I can. And then 2y minus the quantity y squared minus 3, quantity squared with respect to y, and then I type an answer. So when I put this in my calculator, I know I'm going to have to use x's, right? So I'm going to use x squared, right? X squared minus 3. And I'm going to use 2x, but I know that those x's actually mean y's, right? So I'm going to quit out. I'm going to go ahead and hit second enter because, again, I already have this basically in here. So in this case, it is actually y2 minus y1. It doesn't really matter. I'm going to fix it, but here's why it doesn't matter. You're squaring it, so it wouldn't matter what order you subtract it in. But I'm going to fix it just because it bothers me. So I'm going to pick y2 minus y1, right? And I'm integrating from -1 to 3 this time. Notice I am integrating with respect to x, but that's because I'm using x to stand in for y. So hit enter, and there you go. You get a 14.780, right? So the AP needs to see this setup. They're probably giving you 2 to 3 points for that integrand. They're going to give you points for that answer. So in all likelihood, the way these points work, you're probably getting a point for the constant. You're probably getting 1 point for making sure that you have this expression. You're probably getting 1 point for like the bounds and maybe the squared, right? So this is a 2 to 3 point integrand. Sometimes they put the bounds and the constant as the same point. Like sometimes they make this 1 point and then they make the integrand the other point. So it's probably a 2 to 3 point question. All right. And then, oh, to be clear, 2 to 3 points on this and then probably 1 point for the answer. So this could easily be a 3 to 4 point prompt, and it's mostly about interpreting the information and knowing what the setup needs to be for that integrand. All right, let's do one more, and then we'll call it a day. All right, so this is that same region that we've seen probably in P3 of the last video. So perpendicular to the y-axis, we have semicircles. So this is going this way, right, perpendicular to the y-axis, and it's a semicircle. So that means my diameter is the right curve minus the left curve. Well, the right curve is actually curvy, so this is definitely the square root of y. And the left curve is a line, so this is definitely x equals -y. So I know the area of a semicircle is 1/2 pi r squared. And I know in this case, the diameter is right curve minus left curve, which means that's 2 times the radius, right? So that's right curve minus left curve. So my radius is this entire ugly thing divided by 2. Good times. What that means is that your area is pi, 1/2 pi, so pi over 2 or 1/2 pi. And then this whole radius squared. So that's going to be root y minus a -y over 2 whole quantity squared. So there's a couple ways to deal with this. You could type it in just like that. That's fine. You could also go ahead and distribute the squared and make that a 4 on the bottom, in which case you'd get a pi over 8 in the front, and then this thing, quantity squared. When I go to find the volume, I'm going to integrate from the lowest y to the top y, so that's going to be 0 to 2. I'm probably going to put the coefficient out front, so 0 to 2 of this thing minus this thing squared with respect to y, right? And then I'm going to type and get an approximate answer. So I'm going to go ahead and make my my y1 the square root of y, but remember it's actually square root of x when I type it in the calculator because those are my options. And I'm going to make this one a -y, but again, I'm going to use -x, so quit out. So it looks to me like this one is going to be a pi over 8, so second pi over 8, right? Math 9. And then I need my y1 minus y2, so vars over to y vars function y1 minus vars over to y vars function y2, close that, squared, right, comma, with respect to x from 0 to 2. And remember, these x's are actually y's, and then I hit enter, and I get that this is about a 3.609 or 610, depending on if you round or truncate. So this is what your AP needs to see. They're not going to make, you could FOIL this out and integrate by hand, but they're realistically not going to make you. So I did a lot of them by hand in the last video to show you what it would look like, but most of the time you're going to be asked to set it up and then use a calculator to find the volume or just set it up. There are exceptions, but that's kind of the gist. So that's the end of this video.